Hey guys, so the last thing I'm going to talk about on video lecture is neutralization reactions. So as a brief reminder, again, we should think of any acid coming into contact with water. We form H3O plus and A minus, or whatever is left over from my acid. When I put any base in water, I will always form hydroxide, and again, whatever is left over, BH plus whatever it is. But again, I added acid. In water, I will always form H3O plus. I put a base in water, and I will always form hydroxide. Any acid in water forms H3O plus hydronium. Any base in water forms hydroxide, OH minus in water. Now, I should start to think, well, what if I add an acid and a base together? Now, we can think that this is an acid-base reaction where I have my acid, and I'll label it in red. I have my acid reacting with a base, but is water actually a base? Well, no, we consider water to be able to act as a base, but we know water is neutral. Now, when we think of a base reacting with water, again, I label this as my base, and water must be acting as my acid. So water is capable of acting as both an acid and a base. So then what the heck happens when I add an acid and a base together? What happens when I add an acid and a base together is I neutralize. Now, if I add base to an acid, I am said to neutralize the acid. If I add an acid to a base, I am said to have neutralized the base. So we should be thinking when I have an acid and water, again, I've got this H3O plus swimming around. If I add H3O plus now, if I take that hydronium and I add a base, which again contains OH minus, I actually form, well, I form water. I form 2H2O. So thinking about this now, neutralization is really the process of creating something that is neutral, really water. Now, when I think of neutralization, I really think of adding an acid to a base, and what I create is water and a salt. So when we think of neutralization, again, I'm thinking about adding an acid, and we'll go with our most common acid. Hydrochloric acid we're all pretty familiar with, and sodium hydroxide, a pretty common base. Hydrochloric acid and sodium hydroxide, we should remember, according to Arrhenius, what I have here is, well, H plus and Cl minus. Sodium hydroxide, another ionic compound in solution. I know this ionic compound will break apart to form sodium plus and hydroxide negative. Now, when I think of neutralization, again, I should be thinking my acid, and my base forms water and a salt. In this case, the salt that I form is sodium chloride. Sodium chloride, now I should be thinking, well, what the heck happened then? I have H plus from my acid. Again, my acid donates protons, but who is my acid donating protons to? Well, definitely not donating it to chloride, because chloride is what gave the H plus away. Sodium hydroxide, now I've got kind of two players here. Which of these two players would be willing to take on H plus? And we should be thinking about it, this positive and negative. Who do you think is going to want to hang out with H plus more? Well, you should be thinking hydroxide would, because hydroxide is negatively charged. When I have H plus coming into contact with OH minus, what do I form? Well, nothing else but water. So whatever's left over, I've now used up H plus, I've used up OH minus, and what's left over? Well, sodium and chloride, and I have salt. Sodium chloride, which we also said is neutral. When we talk about adding an acid to a base, again, when I add an acid to a base, I form water and a salt. But in this case, what we formed is sodium chloride table salt. When I say a salt, I'm not talking about punching someone, I'm talking about an ionic compound. So when we think about a salt, most of the time what you and I think of is, well, sodium chloride, my table salt. But what if I added HCN, also known as hydrocyanic acid, to sodium hydroxide? A base. Again, I add an acid to a base, I should form water and a salt. But do I form sodium chloride again? Where did that chloride come from? Well, it's not there. So what I actually form is sodium cyanide. Again, my H plus and my OH minus come together to form water. Meanwhile, my cyanide ion and my sodium ion come together to form this ionic compound. Now, salts are defined as ionic compounds that are composed of anything, any ions, except for H plus and OH minus. We know something that contains H plus, we can call that an acid, and something that contains OH minus, like sodium hydroxide, lithium hydroxide, potassium hydroxide, we can call those a base. So if I look at this compound here, lithium fluoride, I can call that an ionic compound. I can also call that a salt. I can call that a salt. When I look at, well, sodium chloride, I can call that an ionic compound. I can also call it a salt. When I say table salt now, when I think of table salt, I know that this is the stuff that I eat. But when I say a salt, just any salt, I could mean lithium fluoride. I could mean sodium cyanide, sodium chloride, sodium iodide. I could be meaning any ionic compound, not just sodium chloride or table salt. So any acid that I add to any base will form water, again, neutral, and a salt, again, neutral. So, neutralization reactions I should be thinking now is when I add a true acid, whatever that acid is that's donating H plus, and some base that's going to form, no matter what base it is, it's going to form OH minus in solution, I will always form water, and whatever positive charge I've got here, and whatever negative charge I've got here, I'll call it, for now, negative charge, I will form a salt. I'll call this something different. Let's just call it negative. Negative. Whatever it is, this salt, this positive charge and this negative charge forms an ionic compound also known as a salt, and I get neutralization. All right, so we will finish up on pH in next lecture. Hopefully you guys have a great rest of your day.